Hello everyone. Today we are going to talk about two different types of data or variables in MATLAB that we have not seen so far. We have seen integers, right? Floating numbers and logical values, complex numbers, and strings, but not when you want to combine them. Can you combine by basically each one of these data under the same umbrella, under the name of this single variable? For example, let's say I have this variable a and I want the first entry of that to be 4. No problem. I want the second entry of that to be 3.12. No problem. You see, when I change the second number to floating, then the first one, the basically number of bits is increased, and now it is also shown with 4 decimals. Now I say I want my third entry to be a complex number, and I say A3 is, let's say, 2 minus 4 times j. Now all three numbers are shown with the complex format, but the two real parts, they have 0 i's. So you see, no problem so far. You can combine floatings with integers with complex numbers, right? Now the problem comes here. I say A4, I want it to be hello world. How about that? I want to bring this guy in as well, and boom, now you got the problem. Why? Because I'm trying to assign basically an array of characters, a string, to what? To A4. You might say, well, why don't you try double quotation mark? Sure, let's do that. Now look at that. It worked. Didn't give error, but look at what it replaced for me for a number 4. It replaced it with nan. So it didn't work, right? Or you might say, well, why do you want to combine letters and numbers, characters and numbers? Why don't you make A4 like a vector or a matrix? I want it to be like 2 and 1, -1 and 3. I want it to be a 2 by 2 matrix. And again, you get the error. Hey, I cannot have such a thing. My previous entries were not 2 by 2 matrix, so I cannot do that. So you see, although I'm not even going to characters, when the dimension changes all of a sudden, not just the type, you have another problem. So if you want to store heterogeneous data, whether their types are different or their dimensions are different, you cannot store them all under the same umbrella, under the same name of a variable, unless you declare this A to be not a regular matrix or even a higher dimensional matrix. Because if you remember when we talked about matrices, I told you that if you want to declare a higher dimensional matrix, then all of the entries of that higher dimensional matrix, all of the pages on it should have the same dimension. So you cannot have the fourth page to be a 2 by 2, but the first page to be what? A single number, a 1 by 1. It's not possible. So the solution to this is what we call a cell array. And a cell array you can create using braces or directly using the command cell. So I can say, well, how about I say AA is equal to a cell of 4 and 1. Now I try to assign entries to this AA, which is a 4 by 1 cell. Now to access the content of cells, if you remember from the lecture on functions and variable arg in and variable arg out, in order to access them, you have to use braces, not parentheses. So I say AA entry 1 is equal to 4. There we go, no problem. AA entry 2 is 3.12. No problem. AA entry 3 is whatever that complex number was, 2 minus 4j or something. A number 4 is what? It is hello world. Can I do that? Yes, no worries. You see? Let's add one more. Let's add one more. Can I add one more? Although I initially said the dimension is 4. Yeah, let's try that. This time I add a 2 by 2 matrix. 1, 2, -1, and 3. Sure, no problem. It's a 2 by 2 double precision bunch of numbers. So you see, I can easily combine heterogeneous data in cells. Each one of them is a cell. And for cells, they don't care what the content is. They don't need to be all the same. Okay, each one of them is kind of like encapsulated into these braces, separate from the others and not affecting them. So whatever you want to put in each one of these elements, no worries, put whatever you want. That's the power of cell arrays, saving heterogeneous data. As I said, if you want to access the content of each one of the entries, use braces, not parentheses. And you might say, what happens if I use parentheses? For example, if I say AA number 5, what happens? It returns that 2 by 2 matrix, but not as a matrix. It returns it as a cell. So it is still in the capsule. It is still not usable with regular matrix commands. So can I say, for example, what is the determinant of the 5th entry of A? No. I can only apply determinant to regular matrices, not to the cell. This 2 by 2 matrix is covered in something. It is hidden in something called cell. I cannot access it. But now, can you access for me the determinant of what? The 5th entry if I use braces? Sure. Why? Because when I say the 5th entry with braces, it brings the content of it without the shell cover, the shell or the cell cover. Actually, it's a shell, really. But yeah, you can call it cell, fine. So without that cover, right, you can access the content, not just access it as a cell. There is also a command in MATLAB called cell to mat. So for example here, remember the AA with parentheses 5 returns a cell. Now there is this command in MATLAB called cell to mat. And this one converts your cell into the matrix, basically accessing the content of it and getting rid of that cell cover. You see? So now can I apply determinant to this guy? For sure. So again, if you want to see inside the shell, either use braces, or if it's regular matrix or a bunch of numbers, you can use cell to mat. But of course, if the entry is a bunch of characters, you cannot use cell to mat, correct? So if you want to access entry number 4, you cannot do such a thing, right? Because the entry number 4 is definitely what? Not a matrix. If you want, you can access it this way, or you can access it this way. But it's just a bunch of characters. So this is about accessing and defining. Now you might say, if I want to define a cell, do I always have to use the command cell? No. For example, I here create a cell and I do not use the command cell. I directly go ahead and create it. By what? I use braces, and these entries, if I want to separate them, I simply do something like this. 1A 4 plus 5 times J. Is that going to work? Yes. You see, I just separate them with comma or space, put everything in braces, that's it. Just like the regular vectors or matrices, I use brackets, I use braces here, and that's it. It creates that for me. I don't need to use the command cell. The other thing important is, what about the way you concatenate these? So for example, if I had this A, right, let me get rid of the last entry in A, correct? So that's A. And then I have B, which is a random of 3 and 1, correct? Can I combine A and B? A is 1 by 3, B is 3 by 1. I want to make a 2 by 3. Can I do that? Sure. I say A semicolon B but transpose of it, correct? Because B is a 3 by 1, not a 1 by 3. So by this transpose, now I make it a 1 by 3. This is another 1 by 3. I concatenate them, I make it a 2 by 3, right? No worries. So to concatenate matrices and vectors, I use what? I use simply brackets, right? Another way I want to do it is I can do A transpose and then space and B. And now this is a 3 by 1, this is a 3 by 1, so you're going to get a 3 by 2. So concatenation is simply done with brackets. What about cells? When you want to combine cells, how would you do that? So here I have A, which is a 5 by 1 cell, and then B is a 1 by 3 cell, AA, sorry. So let's first make them to have the same number of elements and then see if we can combine them. So I come back to the definition of B and try to make it 5 by 1 just like AA. So I add something more, like for example 3.1 and then negative 5, let's make this a matrix, 5, 4, 0, negative 9. Okay, right now BB is what? I made it, but it's a 1 by 5 cell. If I want it to be a 5 by 1, I better use what? Semicolons, right? This way I make BB to be a 5 by 1 as well. Now that they are both 5 by 1, can I combine them? Can I concatenate? Well, yes. One way to concatenate is, can I use brackets just like vectors? Can I say AA and then BB to make it a 5 by 2? Can I? Yes, you can. What's the difference here compared to if you used braces to do it? So you can concatenate two different ways. What's the difference here? When you concatenate with braces, each one of those entities is now considered as a 1 by 1 cell. So now the result here is a 1 by 2, if you look, where each entry in that 1 by 2 is a 5 by 1. Did you see? So the result is a 1 by 2, where each cell in that 1 by 2 itself is a 5 by 1. So it did not really merge them together. It just encapsulated the first one, encapsulated the second one, and then put both of them in a new capsule, in a new shell. While when I use brackets here, it made it a 5 by 2. It really merged all of the content into one thing. So if you really want to merge the contents, use bracket, do not use braces. This is a little bit counterintuitive because everything we have said so far about cells is done using braces, but not concatenation. I mean, not that you cannot concatenate, you do, but it's not probably what you really wanted to do. So the concatenation of content is still done using brackets and not using braces. Okay, that's another thing I want to tell you about braces. Now, remember BB was what? Was a 5 by 1. Can I apply a transpose to it and make it a 1 by 5? Can I use this transpose operation? Yes. You see? It definitely works. So the transpose operation does work on cells. Remember, determinant didn't work, but the transpose does work. Okay, that's one thing. Remember when I wanted to eliminate a component in A, correct? One of the entries in A, I set it equal to what? To empty bracket, right? This is how I eliminated something out of A, the fourth entry. Can I do a similar thing in cell arrays? When I want to eliminate one of these entries, can I get rid of them by setting them equal to empty brackets? So let's say CC equals BB transpose. So now CC is a 1 by 5. Now I want to make it 1 by 4. I want to get rid of this. Or maybe get rid of this third one. So can I say CC entry number 3 is equal to empty brackets? What happened? Did you see? It was not 0. It was a complex number. Now it is 0 by 0 double. But it did not eliminate the dimension. It did not change the dimension. The dimension is still 5 by 1. All it did when I set that entry to empty brackets using what? Using braces, it just set that entry to 0. Did not eliminate it. Now you might say, what if you said that is equal to an empty brace? No difference. Still 1 by 5. Instead of a 0 by 0 double, now it's a 0 by 0 cell. So elimination is not done using braces. We might say, what if I use parentheses instead? Could I eliminate that? Yes. So you see, braces are a little bit tricky. When you want to define them, you use braces in order to define them. Okay? Use braces. When you want to access the content of each entry, you still use braces. When you want to concatenate the contents of 2 cells into a bigger cell, you have to use brackets. And when you want to eliminate an entry or entries of a cell, you set that entry excuse me, to equal to empty brackets, but the way that you do it is using parentheses. Okay, so that's why you have to know how to deal with cells properly and how to access, concatenate, convert, and so on. Okay, that's about that. And we saw one important place that we use cells, that was in functions, variable argin and variable argout, that we use cells. One other thing I want to mention before we end this discussion about cells is when you are trying to combine strings. Okay, so what if you have 2 strings and you want to combine these 2 strings? If you look at the video where I talked about the string manipulations, you will find out that if I have string number 1, which has, let's say, 5 characters in it, A, B, C, D, E, and then I have string number 2, which has, let's say, 3 characters in it, E, F, G, and H, can I concatenate these 2 strings 1 and 2 together? Horizontally, if I say str1, str2, what happens? Yes, it combines them, put them right after each other, and no worries. Now, if I say combine them vertically, concatenate them vertically, now it is not going to like it. Why? Because one of them is length 3, one of them is length 5. So this way you cannot combine strings of different length vertically. They have to be all the same length. And if you saw the vertical concatenation that we did in strings, it had to add some extra spaces, correct? strvcat. It had to add 2 extra spaces to this FGH to make that one also length 5. Then it could do it, right? strvcat You remember that. When you do it, correct? So you see, it could combine them vertically, but to make them the same length, had to add 2 white spaces to the end of FGH to make that one length 5. But you might say, well, I really want to combine these two vertically without changing my second string and adding white spaces to it. Is there any way I can do vertical concatenation? The answer is yes, but instead of considering what? These guys as regular string or character arrays, you have to treat them like cells. Then you can do it. So here I'm telling it, hey, consider this string as the 1x1 cell. This is another 1x1 cell. And don't care what's inside them, just concatenate them vertically, and it does that. And there is no white space added here. Okay, so that's another place where you can do more advanced string vertical concatenations without caring about the length of them using cells. Okay, that's about cells. Now there is one type of other array that is very useful and very important, especially for data entries, and that is called structure arrays. So a structure is similar to the cell in the sense that it allows you combine heterogeneous data all under the same name, the same umbrella. Okay, so in that aspect, the structure is similar to cells. The difference is, as the name structure says, it is more structured compared to a cell. I mean, in a cell, when you have a cell like this, the way that these entries are organized is just based on the number, correct? It's a matrix. It is considered like a matrix. So if I want to access this hello world, what I need to do is to say, go to this answer and then access entry what? Entry row 4 and column 1. Yes? Okay. So the way that these contents are organized is just basically like a regular matrix, and all you need is a row index and a column index. There is no need for the data in each row or each column to have any similarity. They can be of any type, and you access them just like a regular matrix. In a structure, you have really a structure. What do I mean by that? The meaning is this. These structures, they have something called fields. And these fields, they all share the same type of data. So for example, let's say you are somewhere doing some data entry, and you have, let's say, the names, the grades, and maybe the age of some students, and you want to enter them in MATLAB, do some data entry. So you have some type of data, right? One of them, two of them are numbers, age and grade, and one of them is name is a string. So you are storing heterogeneous data, but all of these students, as many as you have, they all share the same type of data. They all have age, they all have name, they all have grade. So let's say you have 10 students. Then you want to say, I create a variable called student. This is an array of 10 members. Each member, which you might call student 1, student 2, all the way to student 10, they all have the same type of data. As I said, they all have age, They all have name and a grade. That's the same for all of them. So what you do now, you come here and you define fields. What are the fields? Age, name, and grade. And then under the field age, for each one of these 10 students, you store all of their ages. Under the field name, you store their names. Under the field grade, you store their grades. Okay, so these guys you call field age. These guys you called field name. And these guys you called field grade. So you see, they all have the same type of data, although this data could be heterogeneous. And that's why this is a little bit more structured than simple cells where each entry can be of its own type, of its own dimension, and so on. So the way to create these structures and access them, access their fields, modify it, and so on, is the topic we are going to see right now. So clear all CLC, let's talk about it. So let's say I have something like this. Okay, I have some students, each one has some name, address, city, state, zip, exam, and so on. And I want to store this data in MATLAB. Now here, instead of having all those 6 fields, let me stick to these 3 fields that I have and create, let's say, what? 4 students. So this is how I create this structure array. I say student or students, whatever you want to call it, with 4 members is equal to a struct. And then in the struct, I provide the fields. I say the first field is age. What is it right now? Empty. I'll fill it later. Then it has another one that is what? That is name. That is also empty. Then there is what? The other field called grade, or let's say grades. Let's make it matrix, basically, on an array. And that is also empty. Okay, so this is a structure array. How many elements are in it? 4. Each one has 3 fields, age, name, and grades. Start them right now with empty. And you see here, it's a structure array with 3 fields. You can see it, it's a 1x4 struct. And now you want to fill the information, do the data entry. So this is what you do. You say student number 1, which right now is all empty. Student number 1 dot age. So the way to access any field is using the dot operation. This is quite similar to what you do when you write objects in MATLAB with object-oriented programming classes and objects, and then the methods. This is what you do with the method dot operation. So you say dot age, student 1 dot age is he's 20 years old. Student 1 dot name is maybe Joe. And then student 1 dot grades is equal to maybe 98, 87, and 92. He's a good student. Good. So now student number 1 is completely defined. If you want, go back and look at student number 1. All the data had been entered for student number 1. Now I do something similar for student 2. Student number 2, she is 22, about to graduate. Then her name is, whatever you want, Alice. And the grades for this third student's also brilliant. Second student, I'm sorry. And let's say she's the top student. So that's 95. Good. So now student number 2 is fully defined as well. Then we go to student number 3. She is a freshman, 18. The name, maybe Jennifer. And then you just need to make sure you don't make a mess. You see, I did, right? Because I said the student number 2 name, you have to make sure it's the student number 3. So let me change the student number 2 name back to Alice. Student number 3 name, that is Jennifer. Her age was 18. Where's the age? Find the name, age, good. And then the grades for student number 3 is, let's say she is a freshman and she's not yet got to work properly with the college standards, so she's not doing necessarily the best, but she's still not too bad. A B, a C, and a D. And finally, we go to the last student, student number 4. He's a sophomore, and his name is, let's say, Alex. And he's also not doing super amazing. So he's about to fail in one of the courses. So now all of these students, student number 4, student number 3, student number 2, and student number 1, they have all been defined with their own data using dot operator, and they're all stored under this simple structure called student, right? So I defined them. Now let's do some accessing the data and manipulation of the data. So let's say somebody asks you, hey, could you give me the age for Joey? So I know Joe is student number 1, so I say student number 1 dot age. That's 20. There is another command that you can do, and that is called getfield. Getfield student number 1 and age. Get the value of filled age for student number 1. That gives you the same thing. Now somebody might say, well, I remember that Joe's age was not 20, he's actually he's 18. So what would you do if you want to modify that? You have to either go and say student1.age is actually 18 to change it, or there is a command similar to that which is called setfield. Set the field for student number 1 and age, set it to 18 actually, it wasn't 20. So now the age is changed. But getfield and setfield, as you can see, they are really not amazing because I can simply use the dot to access it or use the dot and set it equal to something to change it. So these two commands are not really super amazing because I can do it much simpler. One person might come and say, well, I heard that you have this field called student. Could you tell me the name of the fields in this student? What kind of data have you stored for each student? Then there is this command called field names. You say, hey, what are the field names for this structure called student? And it gives you that as a 3x1 cell array. It tells you there are 3 of them, and these are age, name, and grades. Somebody might ask you, how many fields does this structure student have? Can you use something like length? Remember, if you had an array with 10 entries, we could use the command length. Length of A would give you 10. Could you use the command length on a structure? Yes, I can. But what does it give me? It gives me how many members have been in that structure. It does not give me how many fields, of course, and that's what I wanted. I wanted to know this is defined for how many people. If I want to know how many fields are in it, then what? You see, I can look at the length of the answer for this field's name. Can I get the length of this? Can I apply the command length for a cell array, right? Because the result of this field name is a cell array. Can I do that? Sure. So this way you get how many fields you have. This way you get how many members are stored in that structure. Good? Let's go one more level up. Let's say now you want to eliminate a field completely for all of the students or add a new field for all of the students. You want to change the structure fundamentally. What can you do? Let's say I decided that I want to remove the age for all of these students. What can I do? Can I go ahead and say student all of them dot age equal to empty bracket? Right? Because if I simply say student dot age, what does it give me? Please pay attention to this part, it's quite interesting. When I say student dot age and do not provide any specific number, which number, it gives me all of the ages, 20, 22, 18, and 19, but it does not return the answer as a 4x1, it returns it 4 separate times. So if I say set this equal to empty bracket, it is not going to like it. Okay, because that wasn't a 4x1, and setting it equal to empty bracket is not going to work for it. Okay, so you might say, well, what if I want to really access all of the ages of students but as one variable, and then how can I remove it or something, eliminate it? So before elimination, let's just answer this question. If I want to put all of these ages for all of these people into one variable, one, not 4 times giving it to this variable answer, can I put all of the ages of all students in one single variable? Can I do that? Yes. The way to go about it is you put all of those 4 times answers under one single bracket and call it maybe ages. Now look. Now, by putting this bracket around all of those 4 different numbers, it means put them all next to each other and concatenate it. So now this variable ages is actually what? One single variable including all ages. So then you might say, well, can I set this equal to empty brackets? How about that? Now that this guy is all of them together in one variable, can I set it equal to empty bracket? No. Sorry, it's not going to work that way. So what should we do? One of the ways that you do it is this built-in command rmfield, remove field. So you say, hey, remove the field from the student. Which field? The field age. Get rid of it for me. And boom. Now if you look at the answer, it only has name and grades, age is gone, right? But let me show you something that might surprise you. If I say, what is a student? What is the structure array student? What do you expect? You expect it to have only two fields, right? Name and grades, not age, because age I removed. Look. Oh, age is back. What happened? I just removed it. No, you didn't. You removed it from the student, right? But you didn't save the result. You back to student, you get the answer of this removal and saved it to this variable called answer. It's like when you change the name or some information in a file, right? But you do a save as. When you just say rm field of the structure and some field, this is very similar to when you do a save as on a file. The original file is not changed, only you change the new version of it as a new variable. So what should I do if I really want to remove this field in the original student structure and get rid of it? Because apparently here, this is still there. You say, well, remove it and save it back as the original file. Save, not save as. So now, if you look at the student, now it has lost one of the fields. So if you want to save the original, change the original one, make sure to save the result of this removal back and save it as the original structure. This is how you really remove a field. Now, you might say, well, what if I want to add a new field now, a different field? Maybe I had what? I removed age. Maybe I want to add like state, right? Which states are these students coming from? How about that? How can I do that? Well, this is the way to go about it. You add some new field, whatever you want, like temp, and this temp, you define it as a cell. And let's say the first student is from Arizona, the second student is from maybe Colorado, the third student is from California, and then the fourth student is from whatever you want, maybe Nevada, right? So you define it as a cell array, and then you say this. You say student dot states. So all of the values for this new field states that I'm gonna add to students is equal to this variable temp, but all of the entries of it. So here I'm doing vectorization. And now if you see, I have added what? One new field called states for all of the 4 students. So now if you say student number 1, you see the state is added. The student number 4, the state is added. So this is how you add, using these two, a new field. And this is how you remove a field. Okay, so I guess I have covered important stuff about cell arrays and structure arrays, and so I'll stop the video right now. Thank you.